Hello student, welcome to chemistry class. In today's lesson, we are going to be considering the topic preparation of insoluble salts. The preparation of insoluble salts. So let's look at our learning outcomes. The first learning outcome for today's lesson involves you being able to recall the types of oxides and state examples of each of the oxides. You should be able to describe the preparation of insoluble salts by precipitation. And lastly, you should be able to recall how to write ionic equations for precipitation reactions. So the first activity we're going to look at is a very quick one. We're going to look at reshuffling, letters that will form our keywords for today. So I want you to quickly do this in 45 seconds. Yes, try to find out what keywords will fit today's lesson from the letters of these words. Okay, I'm sure you are ready. Let us check the words. The first one, soluble. The second one, insoluble. The third one, precipitate. And the last one, amphoteric. So look at the keywords and see any of these words that you would want to find a meaning to that you do not know before, so that we can appropriately utilize those keywords as we go ahead in the lesson. Okay, so let's look at our quiz, just to record your previous knowledge on the preparation of salt, especially preparation of soluble salt. So focus your mind as you answer the questions on this quiz. It focuses on preparation of salts, specifically soluble salt, and you have 3 minutes for this particular quiz. Okay, let's begin. What is the correct sequence of steps for the preparation of pure sample of copper 2 sulfate crystals from copper 2 oxide and sulfuric acid? Okay. Okay, next question. Question 2. Salt can be made by adding different substances to dilute hydrochloric acid. For which substance could any excess not be removed by filtration? Copper 2 oxide, magnesium, sodium hydroxide, and zinc hydroxide. Okay, so get ready. Question 3. Yeah, question 3. 4 stages in the preparation of a salt from an acid and a solid metal oxide are listed. 1. Add excess solid. Evaporate half the solution and leave to cool. Filter to remove unwanted solid. Heat the acid. So arrange in which order you think should be appropriate. Okay, question 4. Zinc sulfate is a soluble salt and can be prepared by reacting excess zinc carbonate with dilute sulfuric acid. Which piece of apparatus or equipment would not be required in the preparation of zinc sulfate crystals? Beaker, condenser, evaporating dish, filter forming. Okay. question 5. Which method is used to make the salt copper sulfate? Yeah, each of these options, which of the methods? Okay, so I'm sure you are ready to check the answer. So you need to exchange your notebooks. We need to mark this within 2 minutes. Exchange your notebooks quickly. Fine, do that quickly, and let's do a peer marking. Okay, that's fine. So let us mark. Number 1, D, 2C, 3C, 4B, and 5B. Okay, if you have any question pertaining any of the questions on the quiz, then you can raise your hands. Then I will flip back to the question and answer your question. So now let's move on to activity 2. This is going to be an in-class research. So you will be needing your textbook to research, and that research will help you to recall the types of oxides that we have, the types of oxide. So you would work in pairs to research on the types of oxides and use appropriate thinking frames to take notes. So this will take you 10 minutes. Refer to section 11.5 of the complete chemistry for Cambridge IGCSE, and just do in-class research. You need to work, in pair. Pick someone to work with. You're going to read, research, explain to one another, and take notes on the types of oxides that are available to us. Okay, so you have 10 minutes to do this. Okay, well done for the research. I'm pretty sure you enjoy doing the research. So let me do a quick, reinforcement of the concepts that you must have found out during your research, and of course from the explanation that you have given. So we have the types of oxide, 4 types of oxides: basic oxide, acidic oxide, neutral oxide, and amphoteric oxide. Of course, you know the basic oxide, like some of you have explained already. The basic oxides are bases and they react with acids to form salts and water. So basic oxides are usually oxides of what? Of metals. So examples, just take any metal with oxygen, then you have your basic what? Oxide. Copper oxide, iron oxide, sodium oxide, magnesium oxide, and so on and so forth. Okay, so this is an example of what happens to a basic oxide. Basic oxide reacts with acid to form salt and water, like copper oxide plus acid hydrochloric acid will give you copper chloride and water. Okay, we also have acidic oxides. Acidic oxides are usually oxides of non-metals and they dissolve in water to form acids. For example, you can see carbon dioxide dissolving in water to form carbonic acid. So basic oxide, acidic oxide rather, are formed when non-metals react with oxygen, like phosphorus reacting with oxygen, sulfur reacting with oxygen to form sulfur dioxide, carbon burning in oxygen forms carbon dioxide. So basically, when a non-metal reacts with oxygen, it can form an acidic oxide. So acidic oxide would then dissolve in water to form acid. That's what actually makes them acidic oxides. So we have the neutral oxide. Neutral oxides are neither acidic nor basic. So they are neutral, meaning they do not react with either acid or bases. Examples: carbon monoxide, nitrogen oxides. Water itself is a neutral oxide, and dinitrogen oxide, which is known as the nitrous, oxide, and of course we have the nitric oxide, which is nitrogen monoxide. And then we have the amphoteric oxides. These oxides they have the properties of both bases and what? Acids. And that simply means they can react with either the base or what? Or acid. So we have the common amphoteric oxides: zinc oxide, lead oxide, and aluminium oxide. You will need to know the equation for the reactions of each of these oxides with either acid or, a base. For example, aluminium oxide react with an acid here. It can also react with a base. So you can see that the product of the reaction differs. Aluminium oxide plus acid forms aluminium chloride plus water, while aluminium oxide reacting with sodium hydroxide forms a different compound known as sodium aluminate and water. So you will need to be able to know equation that can represent, or that you can write to show that a particular amphoteric oxide could actually react with either an acid or a base. Okay, that's fantastic. Let's move on to activity number 3. Now, in this activity, you're going to do a quick sorting out games. Okay, the person you did the research with, you're also going to work with the person, and you're going to race to sort out various compounds into acidic oxide, basic oxide, neutral oxide, or amphoteric oxide. You will have 5 minutes to do this particular activity. So I'll be looking for the group to finish first. So you have these compounds to sort out under the headings: acidic oxide, basic oxide, neutral oxide, and amphoteric oxide. You have 5 minutes. Your time starts now. Okay, so I believe you're through now. So let's try to do self-marking. So in your notes, what you have, you're going to mark it yourself, and it's going to be over 15. We have 15 compounds to sort, out. So we're going to do the marking in 2 minutes, and you're going to do self-marking. So you mark your note yourself. I believe you have worked effectively with the person you paired with. Okay, so let's get the answers. Cool. So we have the basic oxide, the barium oxide, potassium oxide, lithium oxide, barium oxide, nitrogen dioxide, sulfur trioxide, sulfur dioxide, carbon dioxide. Then neutral oxide, we have water, we have nitrogen monoxide, dinitrogen oxide, and carbon monoxide. Then of course the amphoteric oxide, we have the lead oxide, we have the aluminium oxide, and of course we have the zinc, the zinc oxide. So these are the classifications for sorting out those compounds. So you need to always record the types of oxides that we have. It's very important. You need to know the types of oxide. Okay, so just do a review of the definition of each of the types of oxides that we have. Basic oxides are oxides of metals. Acidic oxides are oxides of non-metal that dissolve in water to form acid. Neutral oxide neither react with acid nor base, while amphoteric oxide can react with acid and also react with a base. I will give 3 common examples: lead oxide, aluminium oxide, and zinc oxide. Okay, so now we'll go straight to the preparation of insoluble salt. The preparation of insoluble salt. Now, previously, we looked at the preparation of soluble salts, and we said that soluble salts are basically formed, when you react maybe a metal plus an acid, a metal plus a carbonate, a metal plus alkaline, or a metal plus base. And usually what happens is that you could obtain the crystals by evaporating the solutions of the salt. Well, of course, not all salts are soluble. So it's very important at this point for you to refer to the table of solubility, because if we want to form an insoluble salt, we need to know examples of those salts that are insoluble. That will help you in the combination of the ions in the salt you will choose in preparing this insoluble salt. So when we say a salt is insoluble, we are simply saying that the salt cannot dissolve in water. So soluble salt can dissolve in water. Insoluble salt cannot dissolve in water. So the table of solubility will actually help us to know these salts that are soluble and those that are insoluble. So quick review of table of solubility. I want you to read, alongside. Just read after me. Everybody, let's read together. Soluble salt. Okay. All sodium, potassium, and ammonium salts are soluble. All nitrates are soluble. All chlorides are soluble except silver and lead chloride. All sulfates are soluble except calcium, barium, and lead sulfate. All sodium, potassium, and ammonium carbonates are soluble. Any other carbonates are what? Insoluble. For example, magnesium carbonate, aluminum carbonate, lead carbonate, and all that will be what? Insoluble. So this table of solubility, as simple as it is, will help you to identify soluble salts from insoluble salt. Okay? So insoluble salts can be made by precipitation. Now, when you say a substance precipitates, it means that it comes out of the solution. So if I have a solution and suddenly a solid appears in the solution, I would say the solid precipitated out of the solution. For example, barium sulfate. If you go back to the table of solubility, we said all sulfates are soluble except calcium, barium, and lead sulfate. So therefore, barium sulfate will be a good example of an insoluble salt. So it can be made by mixing solutions of barium chloride and magnesium sulfate, for example. So if I mix the solution of barium chloride and magnesium sulfate together, so how is it that I'll be able to get barium sulfate? Sorry, if I mix a solution of barium chloride and magnesium sulfate, how is it that I'll be able to get barium sulfate? So let's look at the nitty-gritty, what happens there. So if you look at this solution, this is a solution of barium chloride. So what are the ions present in barium chloride? I have barium ion and chloride ion present there because this barium chloride is a soluble salt. So you would expect that the ions would dissolve in the solution and they would be separated in the solution because now the ions are a little bit free to move about. They are no longer in the solid form. So the ions are what? Are able to move about. They are mobile ions present there. The same thing with magnesium sulfate. Magnesium sulfate is a soluble salt. So you would expect that in the solution, you will get magnesium ion and what? Sulfate ion. Now what happens is that when we mix the two solutions together, there's going to be a reshuffling. Okay, the magnesium will now combine with chloride while the barium ion will combine with sulfate ion. I repeat, the magnesium ion combines with the chloride ion while the barium ion combines with the what? Sulfate ion. So that gives rise to the formation of barium sulfate. Let's look at the equation. Okay, so just see the equation as double displacement reaction. Barium was with chloride, but now barium has divorced chloride. Barium is now with sulfate. The same thing, magnesium was with sulfate, but magnesium has divorced sulfate, and magnesium is now with what? With chloride. So you can see the reshuffling is like a double displacement or replacement reaction. Okay, that will sound better. Okay, so we have the barium sulfate, and since the table of solubility tells us that barium sulfate is an insoluble salt, so we know the state symbol is going to be solid. It's very important that you're mindful of the state symbol. Say solid, state symbol. Then of course, aqueous here will represent a soluble what? Salt. So these salts are soluble. Magnesium sulfate is soluble, aqueous. Barium chloride is soluble, aqueous, and magnesium chloride is soluble, aqueous. But barium sulfate is a precipitate. That's the solid we see in the solution. So it is what? Insoluble. Okay, so writing the ionic equation for this is also pretty simple. So you can see here we have a chloride on this end, and here we also have chloride ion. So we remove chloride ion because it's a spectator ion. It's unchanged on both sides. Okay, we have magnesium ion here, and on this other side too we have magnesium ion. So it's a spectator ion. We cancel it out. But barium ion was a reactant, but there is no barium ion as a product because both barium and sulfate are not dissociated in water. They did not dissolve in water. So their ions are not present, are not solvated in water. So on this other end, barium and sulfate remains as barium sulfate, not barium ion and sulfate ion. So therefore, we are going to retain that in the equation. So barium essentially combine with sulfate to form barium what? Barium sulfate. So we remove chloride and magnesium. They are called spectator what? Spectator ion. It's like they do not take part in the what? In the reaction, because they remain unchanged in the reaction. Now, at this point, you had a pre-work before now, and that pre-work requires that you write, equation for symbol equations for specific reactions. You have 3 reactions that were given, and you are supposed to write the symbol equations for those reactions. Okay, so now bring out your pre-work so that we can assess it at this point. So you have a reaction between sodium chloride and silver nitrate, a reaction between potassium sulfate and calcium chloride, and another reaction between ammonium carbonate and magnesium nitrate. Okay, so you're going to do a self-assessment quickly, and you can ask your question as we assess just in 5 minutes. Okay, so you can see sodium chloride plus silver nitrate. Use your table of solubility to find out the state symbol. The essence of this pre-work is for you to be able to recall the table of solubility and find out what implication will solubility and insolubility have on the state symbol of a particular species in an equation. So you can see silver chloride is solid because silver chloride, according to the table of solubility, is what? Is an insoluble salt. Okay, is an insoluble salt. While sodium nitrate is a soluble salt because all nitrates are soluble, so it is aqueous. All nitrates are soluble, it is aqueous. All sort of sodium are soluble. Okay, so it is aqueous. But you can see all chloride are soluble except lead chloride and silver chloride. And this is silver chloride, so it remains insoluble. Okay, so here too, potassium sulfate plus calcium chloride gives you calcium sulfate and what? Potassium chloride. The same principle applies to it. The same principle applies. Ammonium carbonate plus magnesium nitrate gives you magnesium carbonate and ammonium nitrate. So you can see all sort of ammonium soluble. This is ammonium soluble, ammonium soluble. All carbonates are soluble. All sodium, potassium, and ammonium carbonates are soluble. That's why this is what? Soluble. Okay, all nitrate are soluble. That's why magnesium nitrate is soluble. But magnesium carbonate is not part of the exception for solubility of carbonate. So magnesium carbonate is insoluble. So you have to write S to show that it is a solid at this point. Now, having looked at this, I believe that you now have a thorough understanding of solubility, insolubility, aqueous and solid, and precipitation reaction. So let's look at a video demonstration of a precipitation experiment. And what you are required to do here is you are required to apply your habit of mind, gather information with all senses. So the skill that you have to practice here is observation skill and ability to record, okay, to record what you are assessing together as you're listening or watching the video with your peer. Assess the process and record what you have actually, assessed, and record what you observe in the experiment. Okay, so now when you observe, it's going to be a reaction between lead iodide and a reaction that produces lead iodide, but it's going to be between two soluble salts. So you need to observe critically. Then as you observe and assess the process, you have to write the steps involved and any observations that you observe in your notes. Then also write the ionic equation for the reaction. So this is basically an experiment on the preparation of lead iodide. Even though you are going to write the steps down individually, but you can discuss with your peer as you assess the procedure as a pair, but you're writing down your observation individually. Okay, so I'm going to play the video now and you observe the demonstration. So we want to make lead iodide by precipitation method. So we are going to be needing two reagents: potassium iodide, that's the first reagent, potassium iodide, poured into a beaker. Then we have lead nitrate poured into another beaker. You can see the two solutions are colorless. That indicates that they are, soluble. You can see that they are clear. It means that the two solutions are what? Soluble solutions. Okay, so we'll pour the lead nitrate into the beaker. Then we'll pour the potassium iodide. Wow. Okay, so note your observation. Note your observation. So you may want to suggest, what do you think is being done next? Stirring. After stirring, of course, what do you think will be done? Good. We need to filter. We need to filter. So I want to ask, what will be the residue and what will be the filtrate? So as you assess this procedure with your peer, get your answer in your discussion and note down your observation as an individual. So you find out what the residue will be and what the filtrate will be. Find out what the residue will be and what your filtrate will be. Okay, you can see the filtration procedure. Okay, note your observation. What did you observe? The filtration observation could include what's the color of the filtrate. Okay, what's the color of the residue? Okay, these are the things you note when you are making observation. Okay, look at how the filter paper. Look at how the filter paper was folded together. Okay, so what is being done at this stage, or what is required to be done at this stage in order to get the lead, iodide there? Okay, cool. Yeah. Okay, so I believe you have noted your observation. So you need to answer this question. Yeah, if any of you has something to ask or to add, kindly raise your hand and I'll be able to address your questions. So we are answering this question: why was the mixture filtered? Okay, put the answer in your note. Why was the residue rinsed? Why was the residue rinsed and why was the mixture filtered? Put the answer in your note. Okay, so it's been a wonderful lesson. I want you to state 3 things that you have learned today. 3 things you have learned today. So I'll pick you at random to tell us, share with the class 3 things that you have learned today. So next lesson we'll continue and we'll look into test for ions. In the next lesson, test for ions, cations and anions. Get to your Google Classroom and do your pre-work against next lesson. Thank you.